Welcome back to Low Stress Math with Mrs. Bono. We're going to make a real number flip book. So, take out all that pretty colored paper that I gave you and let's get started. I want you to take the whole sheet of paper, this one, the light purple 8.5 by 11, and the other pieces can go on the side for now. Buy other pieces of paper, I'll need you in a minute, and take your nice big piece of purple paper and fold it in half. So you know how there's a portrait and there's landscape? Well, you're holding it portrait and you're folding it down so that instead of being 8.5 by 11, it's 8.5 by 5.5. Oh, I just divided in my head. There we go. And on the front of this, I want you to put your name up here. First name and last name. So I'm going to put my L. Bono up here. And then you put your period number. So period, and then your number up in the corner. Now, if you don't want your name on the front of this, you can put it on the back, because I am going to hang these up in my classroom, but I would put my name on the front because you should be proud of your work. But if you don't want to know whose work it is, you want to hide, put it on the back. So this is the real numbers. So capital R for real numbers. I'll put a circle around that. And then real numbers. Now, if you don't have great handwriting, you might want to write it first in pencil and then go back over it in pen. But I would really appreciate it if you would write with a dark pen so that I can read it. So do it in pencil if you want, but then go over it with something I can see. All right. Now, I'm going to open this up, and I am going to use this part. I'm going to glue all of these things down on the bottom. So I'm going to put my notes on the top. So what notes am I talking about? Well, the notes that tell me what a real number is. So, for instance, what's a real number? All the numbers on a number line. All the numbers. On a number line. All. What do I mean by all? All right, so I'm going to grab a ruler, and I'm going to come down here, and I'm going to go about a ruler's length above the fold, and I'm going to draw my number line all the way across. And I'm going to try to be neat, but it's me, so it might not be as neat as it should be. If you don't have a ruler, you can use the edge of a book or the side of a piece of paper. Just do the best you can. And put an arrow on each end of my number line. Now, what do numbers lines have? Well, they can have a 0 in the middle, and I'm going to cover up my blotch there and put a 1. And maybe a little further on, I'll put a 2. And then to the left, it's going to be -1, -2. But now, you know that number lines go on forever, so I'm going to put some dots that just say that it's going to go on my numbers. Now, those numbers are pretty far apart for a reason. If you look at a ruler, like my ruler right here, I have a lot of space between my numbers, and there's a lot of little lines. Those are for the increments in the middle. So this line right in the middle of 1 and 2 is 1.5 or 1.5. I'm going to put that right here on my ruler, on my number line. I'm going to go right between 0 and 1, and I'm going to put 1/2. But that could also be written as 0.5. Now on the other side, past the 1, I have more numbers. I have a number such as, if I go 1/3 and 1/3, I have 1 and 1/3, or 2 and 2/3. Those are numbers, 2 and 2/3, Bono. Look at me, already making mistakes, wishing I'd written in pencil. Now when I put my whiteout on there, ooh, darn, doesn't that look really whitey outed? Doesn't look so good, but that's okay. I'm not grading it on how beautiful you write. I'm grading it on what information you have in your folder. So 1 1/3, another way to write that is 1.3 repeating. 1 2/3, well, that's 1.6 repeating. And then I have a number like 2. And 2 can be written a lot of different ways. It could be written as 2/1. It could be written as 4/2. It could be written as the square root of 4. That's the number 2 also. But what about other square roots? Say a little bit further on, almost to the edge here, I'm going to put the square root of 5. Why is that? Well, if I grab a calculator real quick and I take a look at that, and I put in the square root of 5, I get 2.23 blah, blah, blah. But the square root of 5 is a rational number. Now, it's the square root of 5 is not a rational number. It is a real number, and it is on the number line. So I'm going to put my square root of 5 on my number line. It's okay. It's between other numbers. So now, on the other side, I still have some negative numbers. So for instance, I would have negative 1/4. Or a little further on, because 1/4 is 0.25, so negative 1/4 is negative 0.25. But I might have like 0.4 repeating. And if I put that in my calculator, let's take a look at what 0.4 repeating looks like. 0, oh, nope, it's negative bonus, negative goes first, 0 point, and then I fill up the whole screen with 4s, I'm actually going to get the fraction negative 4/9. So that is here too, negative 4/9. And if I keep going, I have negative 1. Let's see, here's another one, negative 1.3, with a bar over it, is negative 1 1/3. Here in the middle would be negative 1.5 or negative 1 1/2. And believe it or not, there's some negative square roots too. I'm going to do negative square root of 3. Now, if the negative is on the outside, it's still an irrational number. I want to show you the difference though. So let's take a look. Negative second square root of 3. If I put that in there and I hit double arrows, I get negative 1.73. That's why I put it over here. It's about negative 1.73. But if I put the negative on the inside, second square root negative 3, it says domain error. That's because when the negative is on the inside, it's not an irrational number. It's not a rational number. It's not a real number at all. And we're doing the real number system. So all my rational and irrational numbers, that's irrational, that's rational, that's irrational, that's rational. All my rational and irrational numbers, all of them are on my number line. So all rational and irrational numbers, all of them are on my number line, and all of those are real. But something like square root negative 3, that comes up as a domain error, those are not real numbers. They're actually imaginary numbers. There's more of them too. If I clear this, get rid of it, and I cleared you, go away. If I make, say, 9/0, if I do that, is that a rational number? Is that an irrational number? No, sadly, that's a division by 0 error. That's not a real number either. So I'm not dealing with any not real numbers. But anything that I can put on a number line, That's gonna be good. So now I'm gonna take my yellow paper and I'm gonna fold it down, and I'm gonna put that on this side. Then I'm gonna take my orange paper and I'm gonna put that next to it. You know, this almost doesn't fit, but handy dandy me has some scissors, so I'm just gonna make it a little bit smaller because I like it to look nice. Now, if you don't have scissors or you don't care that it's not pretty, you don't have to do that. So I'm gonna break this up and I'm gonna put rational numbers on the folded paper and irrational numbers on the not folded paper. So my salmony orange color is on the right, not folded. My golden color on the left, folded. So on here, all the real numbers, they break into rational and irrational. So on one side is going to be rational. And they're represented by the letter Q. That's a little interesting. I mean, this makes sense. Real numbers are an R, but rational numbers are Q. It's going to make sense in a minute. And this is irrational numbers. Irrational numbers, I'm going to do those first. Those are all numbers that cannot be written as a fraction. All numbers that cannot be written as a fraction. In other words, n over d. Both those numbers are integers, n over d. Now, wait a second. Aren't fractions like division? Don't division have answers like Q? Rational numbers are Q because that's quotient. And if you can make a fraction and divide it, then you have a quotient, and that's rational. But if you cannot write it as a fraction, then it's irrational. I knew that Q meant something. Here we go. It's also non-repeating, non-terminating decimals. Non-repeating and non-terminating decimals. And you can check those on your calculator, or you can just remember like pi, 3.1415926, blah, 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 blah. Never ends, never repeats. Square root of 2, never ends, never repeats. Square root of 3, never ends, never repeats. Square root of 4, the square root of 4 is 2. Ah, that does end. That's why I'm not writing it down here. Or you could just have some rando numbers like 0.37486 ... Those are irrational also. So those are going to be my irrational numbers. But in the rational numbers thing, it's going to be a rational number can be expressed as a fraction. So I'm going to open this up, and I'm only going to write on the top here. Remember, nothing on the bottom. That's where the glue goes. Okay. Come on, Bono, you can write. A rational number can be written as a fraction. Anything that you can turn into a numerator over denominator, like say this 0.5 can be a half. 1.3 repeating is 1 1/3. 1.6 repeating is 1 2/3. If you can make it into a fraction, then that is rational. So if it's a repeating decimal or a terminating decimal, then it's rational. a terminating or repeating decimal. And that Q that represents it, Q is for quotient. And anything you write that's a repeating fraction, like negative 0.444, whatever, with a bar over it, is negative 4/9. Or 3/4, which becomes 0 and 75/100, terminates. Repeat, terminates. Or 1/3. Then you have 0.3, repeats. So repeating or terminating, and Q is for quotient because you change them into fractions. Okay, but it also includes more than just those crazy terminating, repeating fractions. It also includes, now you need your pink paper, integers. So inside here is going to go the pink paper, and I'm going to cut this one because it's a little too wide, and I want it to be pretty because, you know, pretty, just like me. Oh, wait, don't lie, Bono. In here is going to go integers. And integers are represented by the letter Z, which is actually the first letter of the German word for number. Yeah, the guy who made this whole thing up was speaking German, but that's okay. Integers are all the whole numbers and their inverses. So, integers are all the whole numbers and their inverses. In other words, positive and negative whole numbers. Those are the numbers that you would write on the number line first. So you would put the 0 in the middle, -1, -2, -3, whatever goes on, +1, +2, +3, whatever it goes on. And the way you would write it as a set would be Z equals, and then remember that crazy thing I thought you had to write for set where it's open and a caret and open? Z dot 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 -2 comma -1 comma 0 comma 1 comma 2 dot dot dot, and then close the set with that backward C and the little arrow. So those are your integers, positive and negative whole numbers. And that is going to go glued inside of here. Now inside of that is going to be the blue paper, which is whole numbers. Whole numbers. Now whole numbers are a W, because that makes sense. Whole numbers begins with W. I like it when it makes sense. Z doesn't make so much sense to me, but it's okay. We'll get there. And whole numbers are all the counting numbers and 0. So all the counting numbers put a dot there, and 0. So you would write the set of whole numbers, sorry, it's crooked. W for whole numbers equals that little curly bracket, 0, 1, 2, 3, dot, 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 close the curly bracket. And 0 is not just a whole number, it is also an integer. It's rational. because it's on my number line and it's real. So it's all of those things. So it's everything that comes before it. It's a whole number, it's an integer, it's a rational number, and it's a real number. If it's inside, it belongs to the group that it's inside of. Now the last group, I see you're happy we're at the end, is natural numbers. And that's your Elmo numbers or your Mickey Mouse numbers. Those are the ones you count. And also, I like that it's just an N for the natural numbers. Natural numbers are counting numbers, all positive counting numbers. All positive counting numbers. And you would write it as N equals curly bracket 1, 2, 3, 4, whatever, dot, dot, keeps going, close the curly bracket. So, for instance, if I got the number square root of 2, I'm lying. That is so bad, Bono, just erase it. Bye. I made a mess. Am I going to get points off for making a mistake and having a mess? No. I'm not grading it on neat. I'm grading it on correctness. So if you make a mistake, it's okay to cross it out. Do it in pencil first. Square root of 4 is equal to 2, which I can make a fraction 2 over 1. So what do I know? I know that the number 2 is what? It's a natural number because I can count to it. It's a whole number. It's an integer. It's real. And it's rational. Like it's there. It's rational. Now, I finished all my work. I'm all done. I can walk away now. No, Bono, you have to find your glue stick and glue everything down. Now, I find it easier, this is just me, I find it easier to put the glue here and then glue the paper on top of it like that. Not gluing myself. So I think it's easier to put the glue here and then put that on top of it and fold it down. And now I gotta glue the blue one into the pink one. So I'm gonna put some glue on the pink one, put that in there, fold it down. Now put some here and put that there and fold it down. You don't have to do it my way. If you do it a different way, it doesn't matter. And then there, and fold it down. And now I want this whole thing to go on that kind of cardboardy paper. You got brown, you got purple, you got a color. I don't know what color I gave everybody, but I'm gonna glue it down on this cardboardy paper. The whole thing gets glued down on there. Whee! Now, like I said, I like my name on front because I like my work, but you could put it on back if you want. I'll see you soon. Have a great day. And remember, it's got to be able to flip open, so don't glue anything shut. Take care. Bye.